Okay, in this video we are going to be looking at moment of force and determination of clockwise and anti-clockwise moment by doing this simple experiment. The experiment is going to be based on possible Waec practical questions. So let me just quickly read through the instructions. So you are provided with this. This is the diagram to guide you through what you are doing. This is a uniform meter rule pivoted at some point, and you have a mass M. Then we have the side P and the other end Q. So let's follow the instruction. You are provided with a uniform meter rule, knife edge, masses, and other necessary apparatus. So we are to determine the mass of the meter rule using the weighing balance provided and record it. So we are going to get the mass of the meter rule. Here I do not have a weighing balance with me, but we can use the principle of moment to determine the weight of this meter rule that we are going to use. Now before that, we have some slotted masses here. So we are going to be using all of this. These are 20 Newton each. So we are going to have 20, we are going to have a 40. So a combination of this is 60, 80, and we have 100 gram mass. So what we are going to do, since we don't have a weight balance here, we can just simply determine the weight of this meter rule by doing this. Now this is my meter rule. I have already pivoted it at the 50 cm mark. So I pivoted it at the 50 cm mark. So you can see the meter rule. Just place it so that it balances horizontally on the knife edge. This is the knife edge. So it balances at the 50 cm mark. So what I'm going to do is to get a mass. So this is 20 Newton. This is a 20 Newton mass. 20 gram mass. So I'll place it on the string. I'm placing it on the string. I'll just place it anywhere on this. So let's say I place it at the 24 cm mark. Now remember that my pivot was at the 50 cm mark, so I have to adjust this so that it balances horizontally on this. So you can see that with the mass, 20 gram mass hung on this, it balances at the 46 cm spot on the meter rule. So what we are going to do now is to use the principle of moment to calculate the mass of this. Remember that I first of all pivoted it at the 50 cm mark. So what we are simply going to do is to get the mass of this way. So the difference between this 24 and 50. 50 minus 24, that is going to give me 26. So the 20 gram times 26 is going to be equal to the mass of the meter rule times the difference between, I placed it at 50 before, so it balances at what? 46. So the difference between 50 and 46 is what? 4. So that will be times 4. So the mass of the meter rule is going to be 20 times 26 divided by 4. So that gives me 130 gram. So I have to do it for two other values to get an accurate value. So I'm placing a 50 gram mass. This is a 50 gram mass placed on this. And the new balance, so the 50 gram mass is placed at the 24 cm mark 2, and the new balance point is now 42. It's 42 cm. So the new balance point is 42. So I'm going to have 42 minus 24. That's 18. So I have the 50 gram mass times 18. Now the new balance point is 42. What we had before was 50. So 50 minus 42 is 8. So the mass is going to be 50 times 18 divided by 8. So I had 112.5 grams. So I have to try to another value and see what we'll get. So using the 50 gram mass at the 22 cm, then the new balance point is at 41.2 cm. Remember our previous balance point where we did not put any mass was at 50 cm. So you have to calculate that. So that is going to give us 50. So I'm going to have 50 times. So the new balance point is going to be 41.2 minus 22. That's 19.2 equals the mass of the meter rule times. So the previous distance was 50. So I have a 50 minus 41.2. So that's going to give us 8.8. So my mass is going to be 50 times 19.2 divided by 8.8. So that will give me 109.1 grams. So if you look at this, these two values are very close. Why this one is far off? So I'm going to use this to take the average of the two. So I'm going to have 112.5 plus 109.1. So that gives me 221.6. So I'll divide that by 2 to get the average. So I have 110.8 grams. So that is the mass of the meter rule. If you have a weighing balance, you will not need to waste your time doing all of this. You just use your weighing balance to get your what? Mass. But since we don't have a weighing balance, I decided to use this to get my mass. Are you there? Okay. Now let's go to the readings proper. So here we go to the experiment proper. We have determined the mass using principle of moment. Now they say we should suspend the mass 20 grams by means of a thread 10 cm from P. This is P. So I'm going to suspend the mass 20 cm from P. So I will use my rope or my string. Now put 20 cm there. Suspend it at So I suspended at the 20 cm mark. So this is my 20 cm mark. Then I have to adjust this. So we adjust it. So we balance the meter rule horizontally. So I have to balance it horizontally. And I take my point of balance. So it balances at 45.3 cm. So it balances at 45.3 cm. So they say we should determine the value of x. X is the distance between the pivot and the 10 cm. So the distance between the pivot and the 10 cm should be, and the 20 cm rather. Oh, sorry. Let's go back. We have to place this at the 20 cm. So from the question, I was supposed to place it at the 10 cm mark. So let me place this at the 10 cm mark. Okay, so let's balance horizontally again. So now it balances at 43.3. So that distance x is going to be 43.3 minus 10. That is equal to 33.3. So I'm going to draw a table. I have my mass in gram. Okay, let me get that. My mass in gram. Then I have x in cm. So the mass is 20 grams and we have 33.3 grams. So they said we should determine and record the value of x, which I have just done, from the pivot while the rule balances horizontally in equilibrium. Evaluate 1 over s. So I have a third column, which is 1 over s, recorded in per cm, because s is in cm. So let's go to 6. Repeat the experiment for m equals 40, 60, 80, and 100 grams. So I have to come to this place and record 40, 60, 80, and 100. So these are the masses. So we have to take other values for values of s for 40, 60, 80, and 100. Then we what? Evaluate. So to get 40 grams, I just add 20 to the previous 20, making 40. So remember, we are maintaining our position here at the 10 cents. So all I have to do is to adjust this, the meter rule on the knife edge, and see where it balances horizontally. So with my 20 gram mass, it balances horizontally at 39.123, 39.3. So the distance between this and this is going to be 39.3 minus 10. That will give me what? 29.3. So that's 29.3. Now I'm going to make the readings for all the others. Then I fill them up. Then I come back and show you how to evaluate this and plot the graph. Okay, to get the 60 grams, I just added another 20 grams to the previous 40 grams to make it 60, and it balances horizontally at 36. So these are the composite table. So I have evaluated on all of this. Now you see that the values of S were recorded or read directly from the meter rule. So I give them to 1 decimal places, and for the evaluated value, you can see that I rounded all of them to 3 decimal places, because that is what is required. You are required to round every evaluated value to at least 3 decimal places. So I have given this to 3 decimal places. Then the next thing for us to do is to draw the graph. So let's see what we are plotting. So we have repeated all of the value, tabulated our reading. So we have to plot a graph of M on the vertical axis. So this is going to be a graph of M. So this is M in grams versus 1 over S on the horizontal axis. So I'm going to write this 1 over S. Let me just write this here, 1 over X. I don't want to put the unit yet. The reason why I don't want to put the unit is because I want to write this in powers of 10, so that I can easily draw my graph. If I want to write this in power of 10, I'm going to write this as 30 times 10 raised to the power minus 3. This is what I've just done. 1, 2, 3. I've moved the 3 places to the decimal. So I write this as 34 times 10 raised to the power minus 3, and this is 38 times 10 raised to the power minus 3, and this is 43 times 10 raised to the power minus 3, and this is equal to 45 times 10 raised to the power minus 3. So easily I can just plot this on this. Now these values are from 20 to 100, so I can easily take my scale on the M axis. So now I can complete this now. This is 1 over S times 10 raised to the power minus 3 per cm. So that's the unit. So remember that whatever values I'll be having here, I'll be multiplying them by 10 raised to the power 3 at the end of my readings. So let's get this. So we are starting from the origin 0, 0. So I have 0, 0. So I can take this to be 10. This is 20. So I have marked out this from 0 to 100. So let me extend this up a bit to 100. I would have shifted it down this way, but anyway. So on this axis, so on the M axis, so this is very important. My scale that I've chosen is 2 cm, because the whole length of this is 2 cm, 2 cm to 10 grams. So I have 2 cm to 10 grams. The unit we use here is gram, not, so you cannot write 2 cm to 10 units. There's a unit for this physical quantity here, which is the gram. So the unit for this should be what? In grams. Then on the other side, I want to try as much as possible to extend the length. If you see that the highest value here is 45, which can extend to 50. So by doing this, I can take 2 cm for this. So if I take this to be 10, this is going to be 20, 30, 40, and 50. So that is our scale. So on this scale, on the 1 over x axis. My scale is going to be 4 cm to 10. Remember that I am taking to this 10 raised to the power minus 3, so that will be 10 times 10 raised to the power minus 3 per cm. So that's the division on this. Now there is one important thing you need to do, how to divide this line. For this it is pretty straight. So what this means is that we have 10 single smaller lines here, and this occupies a unit of 10. So divide that by 10. So it means each of these lines is what? 1 gram each. So this is 1 gram, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now for this, we have 20 smaller lines, and we have 10 on this. So if when I divide 10 by 2, that's 0.5. Each of these smaller lines is going to be 0.5. That means 2 of them is going to be what? 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now the reason why I have taken this to something like standard form is for you to be able to read off the values this here. All you just have to do is to multiply by all of this after taking your what? Value. So let's plot the point. So this is going to be 30 for 20. So I have 20 and this is 30. That is the ease. So put a dot and draw a line, a circle around it. Then the other one is 34. Remember that each of this is divided into two each. So this is going to be 34 for 40. So I move to 40. So this is 31, 2 space. This is 31. This is 32. This is 33. And this is 34. So I'll put a dot on this and draw like this. Then the next one is 60 for 38. So just move up to 60. So we are still in, so this is 35. So I move up to 60. So this is going to be, so this is 60. So remember we are moving to 38. So this is 35, 36, 37, and 38. So I'll just put a dot here and draw a circle on it. So let's go to the next one. So we have 80 for 43. Now, from what we have done, you can see the ease at which I'm reading off this, marking out these values on this graph, because I've been able to reduce this number that would normally be very stressful to this form. So let's go. 80 for what? 43, right? So I'm going to, this is 40. I just move to 80. So I'm going to move, this is 41, 42, and 43. So I'll put a dot here and put this. So the last one is 45. So 45 is directly in the middle of 40 and 50. So this is 45. I'll move it to 100. So I'll put a dot here and put a circle on this. Now, when doing your graph, try as much as possible to open it up. That is what I've done. You see that I stretched this up so that I can have a very large graph. Now the next we have to do is to draw the line of best fit and take our slope. So if I want to draw the line of best fit, let's see, it seems that these 3 lines can fit into the line of best, while this is outside and this is outside. So I've been able to separate 2 of them out of it. So I'll draw this through this. So I'll draw this. Okay, this is out of it. So I'll draw it this way. There is no standard way for drawing this. Just draw a line on this. Then try as much as possible to draw a very large triangle. So let me draw a triangle on this. Okay, let's say this point. So now you can see that I have drawn the triangle. All I need to do is to read off the value. So I'm going to take this point here. So I'm going to have delta m. And here I'm going to have delta 1 over x. Now, don't forget to put the title of your graph. The title of my graph is graph of m in grams against 1 over s in per what? cm. So my slope is just simply going to be this. So let me read off this value here, the top here, to this point. So that is, this is 89. So I'm going to have 89 minus, so I'm read this point down this way, that's 20 divided by, so I'll read this downward, this is 45. Remember, it's going to be 45 times 10 raised to the power minus 3 minus, and I'll push it to this place and read it down. This is 30, this is 29, 29.5. 29.5. So that's going to give me 80 minus 29 is 69 divided by 45 minus 29. 45 minus 29, that is 16 times 10 raised to the power minus 3. So this is going to be equal to, I'll just divide 69 by 16, then I push this up. So 69 divided by 16 is equal to 4.313 to 3 decimal places times 10 raised to the power 3. Now remember, the unit of mass was in gram and this was in per cm. So when this goes up, our unit becomes of gram cm. That is the unit, that is the slope of this graph. If you want to remove this, that will just give us 4,313 gram cm. Now, in all what we have done, if you choose not to perform this experiment, now you can choose not to carry out this experiment by